when we would say A for all are positive, all and their reciprocals, cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent. Everybody's positive. Students, sine is positive. Everybody else will be negative. But hold on, what trig function is built off of sine or comes from sine? Cosecant, because 1 over sine is cosecant. So sine and cosecant technically are positive. All students take. Sine and cosine are negative. Bless you. Tangent is positive, and then cotangent, who's 1 over tangent, is positive. So tangent and his reciprocal, and then all students take calculus cosine, and his reciprocal are the only ones positive. So it's another way of writing what we've actually kind of been using and studying and reviewing. I did it with like little points earlier with plus, 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 minus, plus, minus, minus, plus, minus, but there are a few different ways of seeing it. So if you want this page, I'll leave it up for a second, but let me go ahead and dual page it because I did want us to actually start at the next page, which is reference angles. Let me go ahead and pull this down just a little bit. So I know my projector is a little bit off. Does that help? There we go. So solving for trig functions. The first step solving for trig functions is to sketch. We started doing that yesterday with right triangles, and I have 3 different examples just for us to look at. But solving for trig functions, steps number 1, sketch the problem. Now sometimes, like we saw in the book yesterday in the end of section 4.3, sometimes they give you a picture, so you just get to steal that. But sometimes they don't, and we have to make it ourselves. And when we sketch an angle, that's all well and good, but we're not going to be trying to solve using that outside angle. We're going to be trying to solve using what we call the reference angle. For all of these, I'm going to make alpha the reference angle. You guys remember the Greek letter alpha, right? Yeah. There's alpha. There's alpha. Like, where's Waldo? There he is. There's alpha. We're using alpha because alpha is the acute angle inside the right triangle that we use to solve. It can get a little bit tricky because theta is sometimes outside the right triangle, but still, this theta will have sine, cosine, tangent based on this triangle over here. Same thing here. This huge angle is going to have his sine, cosine, tangent built on this right triangle right here. And this huge old alpha is going to have sine, cosine, tangent, and the rest built on this little triangle right there. So when we're trying to find a reference angle, we have to kind of remember all reference angles are going to be in some way, shape, or form in between the angle and the horizontal axis. We never, never, never draw right triangles to the y-axis. We always go to the x-axis. And in the closest or the shortest way possible. So for this one, we're not going over here, we're just going straight down. For this one, we're going straight up. For this one, we're going straight up. And the first quadrant's kind of easy, you just go straight down. But remember, if we're having to find the reference angle, we have to remember that. Let me go ahead and change it back to blue. This place right here is either 180 degrees or pi. So we might be having to do, if this is in degrees, 180 minus theta to get that alpha. Or if it's in radians, pi minus theta to get alpha. If the angle's over here, this line is still 180 or pi, but this will be a little different. We're going to do theta, the bigger one, minus 180 if it's in degrees, if the angle's in degrees, or theta minus pi if the angle's in radians. Long story short, reference angles are always positive and they're always acute. They're always less than 90. Let me go ahead and zoom in. We should be done with that other page. Just a few of you guys were copying from that one anyway. But reference angles, if you found them correctly, they're going to be always positive, and always acute. It's a cute little angle, less than 90, that's inside a right triangle, formed by the bigger theta, or the theta that could be bigger, I should say, than 90, that could be obtuse. We almost have them? Okay, that's just step number 1. Now on the next page, it still has step number 1, but I want you guys to start copying it step number 2. Step number 1 is reference angle, and I went in some detail about how to find a reference angle. And then, picking up with step number 2. Don't worry, you already have it. Step number 2. Once you've marked your reference angle, once you've found your reference angle, then go ahead and set up a triangle. Now, you kind of saw me sketch them real fast on the page before. But what do you see that's additional? What do you see that's added into these triangles? Not only do you have, now they called alpha, theta prime, whatever. That's our alpha. But then you have to think about, like we did yesterday, which side is which in the sense of, okay, this one, that's comprised or that is helping make angle alpha, that's the adjacent. We have the opposite, we have the hypotenuse. And then based on the problem at hand, we want to fill in as much stuff as we know. We might not know everything, but we want to fill in as much as we know. However, we have to be super careful for signs. Because if you were just doing geometry, you're like, it doesn't matter. Signs don't matter. We're just talking about lengths. But as soon as we're setting this up in like a mathematical plane, we have to say, uh-oh. One direction is a positive direction, one direction is a negative direction. And in application to physics and stuff like that, where you might have forces working against each other, you need to have one be positive showing going one direction, one be negative showing going another direction, and figure out the overall picture. Anyway, those kinds of scenarios, negatives are really important. For instance, if gravity wasn't negative, would anything ever fall? No. Negative numbers are kind of important. So for instance, for this picture right here, we should know that our adjacent is supposed to be a negative, right? Because it's going to the left. Bless you. And then our opposite, what sign is he going to be? Positive. And our hypotenuse, hey, what sign is the hypotenuse always, guys? Positive. Yeah. We never have to worry about the hypotenuse. We always make the hypotenuse a positive number. But for the adjacent and the opposite, as we've already talked about, it depends on what quadrant you're in. And then step number 3 is, I guess easy or I guess hard, but writing it down is super easy. Just solve. Solve for whatever you want. Solve for whatever you need. I shouldn't say want, I should say need. Solve for whatever you need. Okay, now with that, we need to get some examples in, yeah? So, number 1. Find your reference angle. Number 2, set up a triangle. Number 3, solve for the appropriate trig. As always, homework isn't always forcing you to use all these steps at once. That's kind of usually the end of homework. So in the beginning, maybe you'll be splitting this up and maybe just finding reference angles. Maybe you'll be doing the whole thing. Maybe they'll just give you practice with reference angles. So kiddos, the very first step is to figure out a picture because then we can put it in one of those scenarios that we drew for reference angles. So for example, what quadrant is 300 in?
4.
Right? There-ish. True? What reference angle, if this is 300, which it is, approximately, if this is 300, what math are we going to do in order to find the alpha that makes that triangle? What math?
Subtraction.
Subtraction, exactly. What's the whole? 360. What's the part that we have? 300. So what's our reference angle, or the one that I'm calling alpha? 60. Found from 360 minus 300. So in this one we're using 360. Why? Because that's the line that we drew it to. I guess we could use 0 also, but 0 minus, that's going to get us a negative. We want a positive number. What's the struggle with the second one, with B? C degrees or radians?
Radians.
Oh, there's no degree mark, but 2.3, how on earth are we supposed to know what 2.3 is? Well, when worst comes to worst, yeah, let's convert it. So can't we say 2.3 times, it's going to be a little messy, 180 over pi? Now we're gonna do an approximate. Let's see if we can do an approximate. Ready? Now it's a little bit messy. But what's pi-ish? 3.14. So let's say 3-ish. It's going to be a rough approximate, but 3-ish. If we have 2-ish over 3-ish, wait, what's 3-ish and 180? Isn't that 60-ish? And 2-ish times 60-ish, okay, we're going to be really, really rough. We're going to say 120. Probably should be more like 140 or something like that. But we'll say 120 literally-ish. Okay. What quadrant is 120 or 140 or 150 or 127? What is it? All we need to know is where it is. It's right here. Ish. Right? A question. If this is 2.3 ish, isn't this your alpha? The little baby one that goes and hits the horizontal? Now, if we're in radians, what math are we going to do? It's still subtraction.
Pi minus.
Who minus?
Pi minus.
Good, because pi is in radians. We're not going to use the 180. That's for degrees. We're going to use the pi, and we're going to do pi minus. Now, who knows that exactly? No. Oh, cool. What do we do when we have an exact answer and we don't want to mess it up?
Stick it to the man.
Stick it to the man and write it and say, there you go, alpha. That's all right, leave it. I don't want to make it any worse than it already is. Okay, letter C. Whew, it's degrees. That's nice. Letter C is degrees. Oh, but it's negative. All right, come on. You practiced them with negative angles like in section 4.2, 4.3, 4.1. How do we do a negative angle? Go up positive or down negative? Down negative. So we're turning this way. What quadrant is he going to be in?
3.
Good, because I need to go past 90. Where's my reference angle going to be? Right there. And what math do I do to get that reference angle? Kind of subtract. Depends on how you see it. But what's this one? 180, right? Don't you want to know what's in between 180 and 135? So without making a huge deal, why don't we just take away 135, which I guess would be addition of the negative, or just subtract the absolute value, whatever you want to say. The kiddos, what's in between 180 and 135? 45. Why did I not box alpha on the other ones? I don't know. Why does this alpha look like some sort of weird little assorted fish? I really don't know. But either way, we have all of our reference angles, right? So reference angles, draw a picture first. Figure out where that reference angle is going to be, and then you need to do the appropriate subtraction. Wait a minute. What? What's this look a lot like?
Unit circle.
Oh my goodness. Haven't we been practicing this like nonstop? Sweet. Let's keep going. You don't need that. Okay. That was it? Section 4.4 done? Nothing else crazy? We already talked about that too. Oh my goodness. You guys, we're good to go. So let's go ahead, and since we have a couple more minutes, let's do those trig ones that we're like, we're good on.
Or we
Let's
do
check.
homework.
Am I not done the homework assignment with spiral?
Mm-hmm.
Okay, let's do them all speed. Come on. I won't even show anywhere. Cosine, 4 pi over 3. What quadrant?
3.
3. Right? 1 and a third? Over a little bit. Wait, third quadrant. Tangent, negative 210. Negative 180.
5 pi over 3.
Second quadrant is a little
negative.
baby 30.
5 pi over 6.
Square root of 3 over 3, but negative. Cosecant of 11 pi over 4.
What is that?
Sadness.
What is that?
Oh, it's
1 over sine of 4 into 11 is 2 3/4. Okay, hold on. This is kind of like a bonus, maybe? Oh, maybe not. Maybe I didn't give you this one as a bonus. But, question. How do I do 2 3/4 pi? That's not in the unit circle. 1 full time, and then what? That's 2 pi.
Another one.
Now I need 3/4 pi. Where am I going to end up? Just at 3 pi over 4 in the second quadrant. Whose sign? Positive. Root 2 over 2 and flip it. So positive 2 over rad 2. Ugh, rationalize. Long story short. Oops, not rad 3. That's just magic. That's not good magic. Root 2.
spiral bed.
Alright, here we go. We ready?
No.
Didn't I tell you guys to stop doing that?
No.
Yeah, I did.
Yeah, you
You
did.
did?
Just don't.
No more.
I legitimately don't remember you saying that.
Okay, no more.
Then go online at home and do it yourself.
Hey!
Or
Or you take a picture of it. Where's your phone? Okay, I'm proud of you. Good job. Okay, so, still. There we go. Bye-bye. If you really want, I guess you could guess and then do the test review, like guess how many pages. But. Kiddos, I'm calling you to quest. Because it's halfway through chapter 4, but guess how much it's worth? A full test. Why? We need a good one. We need a good one. So let's make this our good one, okay? Make up for the last one. This one's due tomorrow. Look, it's a lot shorter. And if you notice, the notes are a lot shorter. And tomorrow's probably a work day. Sound good?
Oh yeah.
Yay.
A work day, a review day. We've already done a lot of stuff with the unit circle. I might point out at the